Okay, today we're going to look at quadratic formula. I have two examples. We're going to look at an example that has real solutions, and we're going to look at a complex solution example as well. So our steps here are important. Here is our quadratic formula up here, and we have our equation that we're going to solve over here. So let's kind of look at the steps. I've broken it down into three simple steps here. Step one is set the equation equal to 0 and determine your a, b, and c. So at this stage, let's go ahead and do that. So we're going to, the first thing we have to do is get a 0 over here. So I've got to move the 25. So we're going to subtract it from both sides. So we have 2x squared plus 6x minus 25 equals 0. And again, we're going to find our a, b, and c. A is 2, b is 6, and c is negative 25. And we're going to use those in our next step here. Okay, fantastic. So our next step is going to be substitute a, b, and c and simplify the discriminant. Okay, so we're going to substitute them into our formula up here. Okay, so our substitution looks like this. We have x equals, now it says negative b in the formula, so if b is positive, we're going to make it negative. Negative 6, and then we have our plus minus, and then the square root. And when we do the discriminant, make sure you use parentheses around this. Okay, just as a good habit to get into. Every number underneath here, put in parentheses, and that way you can just use your calculator to plug this value in. The discriminant, remember the discriminant is b squared minus 4ac. Okay, so we plug that in, and then we start to do 2 times a down here, so it would be 2 times 2. And then always just kind of verify that you plug the right stuff in. Just kind of go back through it mentally and check and make sure you put the right pieces in the right spots. Now I said our included in step 2 is simplifying the discriminant. So I'm talking about the part underneath here. So I'm going to highlight that for you. So I'm talking about this part right here. Great. So we're going to do 36 plus 200. So that's going to be 236. Now again, just go ahead and use your calculator for that. Be good. But that value is 236. Okay, so we have x equals negative 6. We erase that there. Do a little better drawing here. Okay, so we have x equals negative 6. That's not much better, but you get the idea there. So we have plus or minus the square root of 236 all over 2 times 2, which is 4. Okay, so this is a negative 6. Okay, let's go ahead and look at step 3. We've simplified our discriminant down to 236. If needed, simplify the solution and check your answer using a graph for real solutions. So we can only use the graph to check real solutions. So 236, if you look at that, that's actually going to be 4 times 59. Now you can use a factor tree for that, however you want to do that. I've covered that in a previous video. We're just going to show the step here of simplifying this discriminant. I'm going to move this out of the way. Okay, so we got x equals, okay, I got a pen here. So x equals negative 6 plus or minus. And since we had 4 times 59, we're going to take the square root of 4 and take that outside the radical. So that's a 2. And then we got a 59 here. Okay, and then that's all over 4. Now, the first thing I notice here is that I have a common factor between 3 of these terms. Let me go ahead and circle this for you. These 3 are connected. You can't just divide out these 2 and simplify that to negative 3/2. You have to include this with it. So as we do that work, this is what it looks like. So we have, they're all divisible by 2. So our answer is negative 3 plus or minus the square root of 59, because when I divide 2 by 2, I get 1. So it's 1 square root of 59 all over 2. And this is our final answer right there. Okay, so that's our final answer. Now I'm going to show you on the calculator how we can check that. Okay, so I've gone to my calculator and I've plugged in these, we call these exact solutions here. Negative 3 plus the square root of 59 divided by 2, and negative 3 minus the square root of 59 divided by 2. Notice our plus minus is taken care of here. And the reason I did this to show you how when we have real solutions, even though they're exact with square roots here, they can't be simplified, we can turn these into decimals and get approximate solutions. So this is to 10 spots here. So we're gonna now look at the graph. And so and just confirm that this crosses at 2.34 for x and negative 5.34. So again, what I do is I use my y equals. I'm going to put my equation in there just like that, and then we're going to look at the graph. And sure enough, when we look here at this spot, that's about 2.34, and this is about negative 5.34. So we've confirmed our solution here for this quadratic. Again, that's how we can check it. Let's go ahead and turn our attention to the complex numbers example. Okay, so here's our complex numbers example, and again we're going to start with the same steps that we used last time. So set equal to 0 and determine a, b, and c. And you notice here it's already set equal to 0, so that part's done. We just need to determine a, b, and c. So we have a equals 3, we have b equals negative 5, and c equals 3. Okay, so at this point we've determined a, b, and c. We're ready to go ahead and move on to step 2. It's going to be substitute a, b, and c and simplify the discriminant. Let's go ahead and do that. So we've got x equals negative b. Now notice this time the b is negative, so we're going to make it opposite. A lot of times I teach that think about that as opposite b. So we'll put a 5 there, and then our plus minus. And we've got our square root of b squared. Again, we're going to use parentheses, especially on a problem like this, where we're going to get a negative discriminant. That's 4 times a times c, and that's all over 2 times a. And again, just verify that you plug the right stuff in where it belongs. Kind of take a second to mentally check that. 4 times a times c looks good. Okay, and we're going to simplify the discriminant. So we're going to do x equals 5 plus or minus the square root. In this case, the discriminant reduces down to negative 11 because we're doing 25 minus 36. We have negative 11. And of course, at this stage, I always kind of simplify the denominator too, so that becomes a 6. Okay. Now at this point, we're mostly done. We do need to get rid of the negative underneath the discriminant, or underneath the radical there. It says, if needed, simplify the solution and check your answer using a graph for real solutions. Now the issue with this one is I can't use a graph to check the solutions. But what I can do is we can see if it crosses the x-axis, because since we have 2 complex solutions, here they are with the plus minus version, at this point when we go to graph this should not touch the x-axis because the solutions are on a complex ordered pair. So let's go ahead and take a look at a graph and just confirm that at least it doesn't cross the x-axis. Okay, so I've placed the equation into my y equals. Now I'm going to go look at the graph. And sure enough, we notice it never touches the x-axis. So we haven't confirmed our complex solutions that they're correct, but we do know at least we're on the right track in terms of what type of solutions we have. So that at least helps us out with that. Okay, I hope you enjoyed the video, and hopefully it helped. Good luck with quadratic formula, and remember, it's a fun puzzle. Try to have fun with it, and I will talk to you in section 9.3.